On February 27, 2020, ISRN uploaded a video entitled, "A Gadget Camera Recorded the Real Fajr in Medina." In the video, we explained detailed steps in constructing and processing the mathematical model to precisely determine the appearance fajr from a series of digital images. Now, we are preparing a video to explain steps on whether or not the estimated presence of the fajr is verifiable. Unlike the data collected using the non-imaging sensor such as the Sky Quality Meter (SQM), the verification using the existing images is a lot easier. We can apply the 3D surface modeling of the distribution of the pixels in an image. It is a case study whereby we prepare a video entitled, "A 3D Surface Model for Fajr Verification in Medina." First of all, we would like to demonstrate how easy to support crowdsourcing data collection using a mobile phone. On February 3, 2020, Mr. Rizal sent a WhatsApp message. He was performing Umrah, and his hotel was facing east and very ideal for Fajr observations. I then suggested installing Lapsit on his cell phone to collect remote sensing data. 2 days later, on February 5, 2020, he collected the data. He uploaded it to his Google Drive, and I then downloaded it in Jakarta. Brief guidance for Lapsit operation is available at the end of this presentation. The results are as follows. This slide explains the summary of the construction of the mathematical model to precisely determine the presence of the fajr from a series of digital images. We have revealed it thoroughly in our previous video. Mr. Rizal took his series images actually since about 4:30 early morning, almost 1 hour before official fajr in Medina at 5 hours, 41 minutes, and 57 seconds, on February 5, 2020. However, all the photos are pitch black because the real fajr the day occurred even some 36 minutes later than the official fajr, as shown then. The change in the sky brightness pattern is only identifiable when we tried to plot the standard deviation of the image ID 591 until 697. The figure on the right shows the trend. The x-axis shows the exposure time of the image, while the y-axis shows the corresponding weighted standard deviation of the digital image. The data source of these primary axes is these two columns on the left table. This column indicates the exposure time, and this is the column for the corresponding weighted standard deviation. In our previous video, we have shown that the standard deviation is a measure of the pixel distribution in an image. We have also shown that the more significant the standard deviation, the brighter is the image due to the more spread of the pixel distribution. This figure further demonstrates the graphical procedure of how we precisely determine when the real fajr occurs. From the mathematical model, we can estimate the extreme point of the polynomial at 6 hours, 18 minutes, and 2 seconds. Mathematically, it is precisely the instance when the real fajr present on February 5, 2020, in Medina. At that point, the sun was at its depression angle of minus 10.42 degrees, a lot less deep than the official depth of minus 18.5 degrees. Therefore, the real fajr occurred some 36 minutes later than the official call for prayer recited at 5 hours, 41 minutes, and 57 seconds. As such, the real twilight was only about 44 minutes, not 1 hour 20 minutes like officially estimated. It is because the sunrise remains the same at 7 hours, 1 minute, and 50 seconds. However, one might raise an inquiry as to how we can verify the presence of the real fajr at 6 hours, 18 minutes, and 2 seconds. It is one way of ascertaining it using the 3D surface modeling analysis. This slide shows the 3D surface model of image 607 taken at 6 hours, 17 minutes, and 2 seconds. In the graph, it is precisely 1 minute before the presence of the real fajr. Everything in the picture is pitch black, indicating that the real fajr had not been present. The mountain range-like appearance in the 3D surface model is the contribution of the heavy traffic surrounding Medina city before the official lockdown due to the COVID-19 pandemic. This summit is representing the brightest spot in the image 607. The next slide is a 3D surface model of image 609 taken 20 seconds later at 6 hours, 17 minutes, and 22 seconds. Again, everything is pitch black, as also shown in the plot. We can continue until image 613 taken at 6 hours, 18 minutes, and 2 seconds. It is where the mathematical model estimated the presence of the real fajr. However, naked eyes might not be able to perceive its presence in the 3D surface model. Naked eyes only able to perceive its presence some 2 minutes later after the real fajr on image 625 taken at 6 hours, 20 minutes, and 2 seconds. It then goes exponentially more apparent in the following 3D surface models. We stop our 3D surface model analysis at image 697 taken 6 hours, 32 minutes, and 2 seconds. In the next slide, we put the 3D surface model side by side with the original image 697. One should not be alarmed, however. Despite the much glowing horizon in the east, it is only 14 minutes after the presence of the real fajr, and it is some 30 minutes from sunrise. Therefore, one still has plenty of time to perform the fajr prayer. Conclusion. There was no fajr before 6 hours, 18 minutes, and 2 seconds in Medina on February 5, 2020. Gadget camera is a versatile tool for recording the fajr. 3D surface modeling is a reliable way to verify the presence of fajr. Crowdsourcing is the most reasonable scenario to prepare for the compilation of global twilight. Evidently, with very minimal directives, Experiment Resolve was able to obtain fajr data, one of the best of the 700 data that ISRN had. To find the truth about the presence of the fajr, ISRN is seeking an opportunity to have discussions with other experts in the world, including with the Islamic Society of North America, Al-Qura University of Saudi Arabia, the European Council for Fatwa and Research headquartered in Dublin, Ireland, the World Muslim League, and so forth. From some 700 days of astronomical and remote sensing data collected in 7 different parts of the globe, our estimated depression angle of the fajr presence tends to rest at -13 degrees. The data cover Indonesia, United Kingdom, the USA, Egypt, Turkey, Saudi Arabia, and Malaysia. We are curious about what are the grounds that ISNA applies -17.5 degrees, Saudi Arabia is using -18.5 degrees, Egypt authority uses -19.5 degrees, and so forth. The following slides will give concise technical guidance for LabSit operation for those who are interested in contributing to the crowdsourcing movement we are promoting. First of all, please install LabSit from the Google Play Store. When you click the icon, it will bring you to its landing page like this. Before pressing the new capture button, first of all, you have to check the setting by pressing the available button. Set the frame interval at 10 seconds. It is the rule of thumb of having a 10-second frame interval. As the accuracy of a prayer timetable is about 1 minute, therefore, the data for the estimation must be smaller than 1/3 of the precision required. You might want to have a 5-second frame interval, at the cost that you double the number of the frame. Put the limit mode as user, so that the camera will continue operating until you physically stop it. If it is possible, set the initial delay to 100 milliseconds. Focus mode to infinity. Put the shutter sound to enabled so that you can hear the camera is working, and you can listen to the clicking process. The free version of LabSit only gives you a maximum geometric resolution of 460 rows and 640 columns. Alternatively, LabSit Pro will cost you a little bit of money to pay with an option that you can apply maximum geometric resolution of 1080 rows and 1920 columns. Set the rest settings to the default. Then you go back to the home and press the new capture button, and the camera will automatically acquire the data. Continue to obtain the data until about 10 minutes before the sunrise. Interrupt the data collection process by touching the screen and press the stop button. Touch the gallery button to check if the project is already in your mobile phone's memory. You might have several projects, the one on the top is the latest. Touch it and check the timestamp box. It will then show you image exposure time until the second level. Take note of only the first image until the second level. Otherwise, the system will only record the timestamp until the minute level, and we can only guess the timestamp of the second level. Lastly, touch the Zip and Send button to store it in your own Google Drive or OneDrive cloud. Send the address of the zipped file to me, and inshallah, I'll process the data for you, free of charge. Your contribution will be acknowledged and highly appreciated. Assalamu alaikum wa rahmatullahi wa barakatuh.